going to have, let's say, choose the name, right? Choose the name of the, choose the circle destruction corresponding to the IUPAC name that we have. So 3-chlorobenzoic acid. You need, there is only, actually, this is an easy one, right? There is only one acid. You know, unless I made a mistake, that's the only acid from the group. This one is an aldehyde, this one is an ester, right? So that's the only one that can give you the acid. Methylpropionate, you are looking for an ester, and there are two esters in the group. The first one we already discounted is a chlorine, so there are two esters in the group. So you are going to look for the one that has the methyl group, methylpropionate, right? Which one is it? The last one, because the methyl group refers to the alcohol part of the ester, right? This is the methyl group over there. N-methylpropionamide, it means we have an amide, and on the nitrogen it has a methyl group, right? And that is the middle one, right? Okay, then cyclohexanamine, the first one, right? Anybody has any objections? Okay, glycerol tripalmidate. We are looking for a triester, right? Only the first one. Okay. This single the structure that corresponds to each statement. Phospholipid, we are looking for a molecule that has phosphorus, right? That's the phosphorus. Steroid, typical steroid structures, right? The 3 6-member rings with the 5-member ring, that's the steroid skeleton. You should be able to recognize it. Secondary amine is the one that the nitrogen is connected to 2 carbons, right?
Second one.
Wax, it's a long chain alcohol with a long chain organic acid. Lactone is a cyclic ester, not a cyclic acetal. Lactam is a cyclic amide. Tertiary amide is the one where the nitrogen is connected to 3 carbons. Heterocyclic amine, the amine where the nitrogen is part of the ring, right? Yeah. Aromatic amine, the one that is attached on an aromatic ring. Quaternary ammonium ion, the one that has 4 carbons attached to the nitrogen, right?
Oh yes, it is the first one.
4 carbons attached to the nitrogen. The last one, this one has only 1 carbon attached on the nitrogen. Okay, from each pair circle the compounds best described. The molecule forms dimers, alcohol or acid? The acid. Only the acids form dimers. That's why they have higher boiling points than the alcohols. Molecule can form polymers. You need to have a bifunctional molecule to form polymers, right? The one that has 2 functional groups, hydroxyl group and the carboxylic group. Higher boiling point, an alcohol and an amine. Which one has higher boiling point? Alcohols. Stronger hydrogen bonds. Higher boiling point, tertiary amine with the primary amine. Primary amine has more hydrogen bonds. Saturated lipid, the one that has only single bonds on the chain. Higher melting point, solid at room temperature, the unsaturated lipid. Okay. Nucleophile. Which is the nucleophile? First one. Oops. I keep forgetting again. Okay.
Alright.
Electrophile,
First
with positive charge, has to be electrophilic.
This one.
Can form hydrogen bonds.
First one.
You see, you are getting better. 2 weeks ago, when I was doing the same thing, I had to give her the answers. Now you are giving the answers. Has a hydrophilic group.
How do you know?
Okay.
What else?
So, hydrogenation of the glycerol, triolate, produces the glycerol tristerate. At the temperature, please explain why the product is solid. Right? We have the conversion of the double bonds to a single bond, right? So, why is it solid? Okay, now is where we start. The whole idea here is that the double bonds disrupt the alignment of the chains, right? Remember when we spoke about it? When we have the chains, the strands of these molecules, right? Here, the single bonds allow the strands to be parallel to next to each other to have maximum non-polar interactions, random forces, temporary dipole-dipole interactions, however you want to do it. But the alignment, the single bonds, the way they are, allow them to align next to each other, to be parallel, ensure the maximum interaction, ensure the highest boiling, the highest attractive forces. The double bonds, they disrupt this alignment. They do not allow them to have this maximum interaction. Therefore, the attractive forces when we have double bonds are going to be much smaller. And when the attractive forces are smaller, then you have a liquid instead of a solid, right? The fat, the saturated fat is going to be solid. Propanol has a boiling point of 97 degrees and the acetic acid of 118 degrees. How do you explain the difference? We already said it before. The acetic acid makes dimers, right? So, dimers. Acetic acid makes dimers. And if you are good, you are going to draw the dimer structure, right? It's going to look like with hydrogen bonds between the hydroxyl groups. And that's basically their only difference because both of them are polar molecules, both of them make hydrogen bonds. The only difference is that the acid is going to make a dimer. Okay, answer 2 of the following. The boiling point of methyl acetate is 58 degrees and the boiling point of propanoic acid is 141 degrees. You notice that I use molecules that they have the same molecular weight. So to prevent you from the temptation to say one is bigger than the other. One is not bigger than the other. They have the same molecular formula. The only difference is that the propanoic acid makes hydrogen bonds. Propanoic acid makes hydrogen bonds, so it has stronger attractive forces than the other one. The boiling point of butanamine is 78 degrees Celsius and the N-dimethyl ethanamine is 38 degrees Celsius. The primary amine makes hydrogen bonds. This one, no hydrogen bonds. That's the difference. Otherwise, both molecules are polar molecules, similar polarity, carbon and nitrogen. So their only difference is justified by the difference of hydrogen bonds. C, the boiling point of butanamine is 78 degrees and the boiling point of butanol is 118 degrees. Why? Both of them make hydrogen bonds, but the butanol makes stronger hydrogen bonds. And when you write that, that's not enough answer. Why does it make a stronger hydrogen bond? Oxygen more electronegative. Okay? To get all points, you need to write both. Okay? The oxygen is more electronegative, therefore the alcohol makes stronger hydrogen bonds, therefore the attractive forces are larger and so forth. Okay. Circle the product for each of the following acid-base reactions. Okay, remember we have acids and bases here. We have benzoic acid with sodium hydroxide. So what's going to be the product? It's going to be the salt, right? It's going to be the sodium benzoate. Aniline with hydrochloric acid. This is going to be the product. Sulfuric acid with sodium stearate is going to release the acid, right?
Oh.
Ammonium chloride with sodium hydroxide. The dimethylammonium chloride with sodium hydroxide. Which one?
Second one?
First one. The amine. It's a salt of the amine. It's a chloride salt of the amine. We have acetic acid with methylamine. First one. Right?
Green. Oh.
Okay, let's see how good you are on this one.
No.
Alcohol, primary alcohol, converted to acid.
Okay.
Is the oxidation, right? Cyanide, converted to acid. Yes, sulfuric acid, water, hydrolysis reaction. Azide, converted to amine. Acid converted to the ester.
B.
And no choice, right?
I have to say B after it was fucking clicked already.
Okay. In the spacing provided. Okay. Amide reacting with sulfuric acid, heated, and water. The product is E. Okay. Okay, your word for it. Hydrogen cyanide, hydroxy, the cyanohydrin, heated with sulfuric acid. The answer is the hydroxy acid. Amide reacting with water. You sure? I'm not even looking. The triglyceride reacting. The answer is? You sure?
Yes.
Is that a trick question?
And the last one is? Okay. 9. Circle the product in each of the following dehydration reactions. It's giving you a pointer, dehydration. That means they are losing water, right? So the first reaction is going to be an esterification reaction. So you are looking for the ester. The second reaction is the formation of the amide, right? So looking for the amide. The third reaction is the transesterification reaction. So you are looking for this one. The replacement of the triol with the methyl group, basically. Then reaction, the last one we have, it's a polymerization reaction basically. So it's going to be which one? First one. And the last one is it's an easy one, the middle.
Okay. Not even like
Right? It's the formation of the benzamide, dehydration of the benzamide. Okay. Question number 10. Circle the product in each of the following reactions. Okay. We have the first reaction of acid halide with cyclopentanol, diethylamine. This is the formation of ester, right? The first one, where the alcohol part. The second reaction is the acetyl chloride reacting with the amine. The answer is first one, formation of diamide. Third reaction, hydrogenation of the cyanide, making the amine. Oxidation, mild oxidation of an aldehyde. We are getting the acid, right? Replacement by thionyl chloride reaction with the acid. We are replacing, that is the replacement of the hydroxyl group. Whenever you see it, you replace the hydroxyl group with chloride. And the last one, reaction, it's a polymerization reaction basically. The first one.
I'm actually on the light today.
Okay, people, any questions?
Yes.
Please sign the attendance.
You ate that up, though. You actually ate. You see, that's what got me good. Oh, yeah.